Let's look at the squeeze theorem in this video. Consider if you have function f of x between function h of x and function g of x like this. Let me see you have it this way. Function g of x. You observe that I have this function f of x between function g of x and function what? H of x. Now, take note of something. If the limit as x tends to a value a of g of x is equal to the limit as x tends to a of value what? H of x to be L. It means that by squeeze theorem, it means that the limit by x tends to a of f of x will be equal to L. Let me explain this squeeze theorem. This is the statement that if you have f of x between these two functions, that is, if f of x is squeezed between function h and function g, just as you have it here. And if both of them like this, if these two functions approach the same answer when x tends to a, then f of x is forced to have the same answer of that their limits, and that is the statement of the squeeze theorem. Now, I'll be looking at some problem to explain this squeeze theorem better. Now, let's look at it. If I have, for example, I have the limit as x tends to a, as x tends to 0 of x squared sine 1 over x. Now, pay attention to something. Did you know that in trigonometry, sine and cosine have minimum value of -1 and maximum value of 1? It means that I can rewrite this as -1 less than or equal to sine 1 over x less than or equal to 1. Then, if you observe, when you have something like this, try to make this middle term just like the question you have been given. If you are able to establish that, then you'll be good to go. Now, what I'm going to do here is that what I'm going to multiply through by x squared. Then I'll be having minus x squared less than or equal to x squared sine 1 over x less than or equal to x squared. You observe that I have successfully made this middle just like the question I have. Then you apply the limits. That therefore I have the limits as x tends to 0 of negative x squared less than or equal to the limit as x tends to 0 of x squared sine 1 over x less than or equal to the limit as x tends to 0 of x squared. Now, don't bother about this. Answer this question. What's the limit as this one tends to 0? What will be my answer? My answer will be 0 less than or equal to the limit as x tends to 0 here, x squared sine 1 over x less than or equal to this will give us 0. Do you observe that since this function here is squeezed between this and this, and both of them approach the same answer, they approach the same value after evaluating the limits. Therefore, it means that the limit as x tends to 0 of x squared sine 1 over x will be equal to what? 0. This one is squeezed between both of them, so it will have the same value for the limits, and that's equal to what? Equal to 0. Let's look at another problem. If I have the limit as x tends to 0 of x cubed plus x squared sine pi over x, we are asked to evaluate this. So when you see something like this, of course, we make use of the squeeze principle. But firstly, start from the trigonometry. You start from the fact that sine has the minimum value of -1 and the maximum value of 1. Good. Now, from here, try to make the middle term just like the question you've been given. All right. So let me do that. That is minus 1 less than or equal to. For me to make this same thing as what I have here, I'll have to multiply through by everything here. See, if I multiply through by everything, I'll be having negative square root of what? X cube plus x square less than or equal to square root of x cube plus x square, then sine pi over x less than or equal to positive square root of what? X cube plus x square. Now, from here, what do we do next? We apply the limits and let's see what we are going to get. Let's apply the limit. That is, I have the limit. I'm applying it to what? Negative square root of x cube plus x square less than or equal to the limit square root of x cube plus x square sine pi over x, then less than or equal to the limit. I'll still put what it tends to. Square root of square root of this, and this is what I have. Now, let's evaluate this limit. Remember, the limit is tending to 0, and this is tending to what? 0. So let's see what we have from here. Let's see what we have from here. What we're going to do from here is that let's evaluate these limits here. Remember, if I plug in 0, this part will give me 0. Also, this part is what I don't know. That's what I'm trying to look for. And also this other part will give me 0. You can see since this is squeezed between 0 and 0, therefore the limit as x tends to 0 of square root of x cubed plus x squared sine pi over x, this will also be equal to what? 0. So that is the squeeze theorem. Let's look at one more problem. Let's look at one more problem. Okay, if I have if I have if I'm to evaluate this limit as x tends to infinity of 5x plus cos x all over 3x minus 2. All right, what do we do from here? Firstly, start with this cos x that you have. Remember that it has a minimum value of minus 1 and maximum value of what? Positive 1, just like the sign. My job is to make what I have here model what I have here. That's just it. So how do we do that? So you have minus 1 less than or equal to. The thing is that, see, add plus 5 to each of the 10. So if I add 5 here, I'll have 5x, then, I'm adding 5x, then this is 5x plus cos x. Then if I add 5x here, 1 plus 5x. I'm almost there. The last thing for me is to divide through by 3x minus 2. So divide through by 3x minus 2. Divide through by 3x minus 2. So what do we do from here? After that, apply the limit. So I have the limit as x tends to infinity. I have the limit as x tends to infinity. And I have the limit as x tends to what? Infinity. Now, remember our shortcut. Remember our shortcut that if this limit tends to infinity, what happens? We'll just pick the coefficient of the highest powers of x here, which is 5 over 3. This one also 5 over 3. Because since this is squeezed between 5 over 3, therefore the limit as x tends to infinity of 5x plus cos x all over 3x minus 2 is equal to what? It's equal to 5 over 3. So that is the explanation on squeeze theorem.